which we can focus on. And also some of the researchers across the globe are also working parallelly. Even then the fusion reactors are already been established, and other concepts are also parallelly being practiced. But the thing is that the resource, I mean, since it is a renewable energy resources, it is an inexhaustible nature of the fuel, so that it have been drawn the maximum of attention out of the researchers and academicians, including the scientists across the globe. So, firstly, as I was likely mentioned, that the sustainability is one thing that we need to focus on in recent time, and also for the future generations. Before that, the law of conservation of energy states that we cannot produce the energy, or we cannot destroy the energy. We can convert one form of energy existing into another form. That is likely to be applicable for all the renewable and non-renewable energy resources. So as I have already been mentioned, that we have been taken the biomass as one source of energy for converting this biomass into the directly into the combustible form of a producer gas, or the syngas, through this technology called the gasifiers. So this has been taken, but before that, we just wanted to discuss all the other energy resources, and based on what we have taken this biomass as a source of energy for this, I mean, the gasification technology. So that the energy conversions can be made through in two different ways. One is of direct energy conversion systems, and through the indirect energy conversion systems. In the direct energy conversion systems, if there is no existence or the involvement of any rotating component, then we call it as a direct energy conversion technologies. And if when it comes to the indirect part, where the rotating component is being involved, such as the rotors, and also the windmills, it is not about the renewable or non-renewable energy resources. It is about whether the rotating component is involved or not. We are in thermal power plants, nuclear power plants, and also the wind energy conversion systems, where the rotating component is involved. We call it which have been kept under the indirect energy conversion systems. Whereas in the direct energy conversion systems, the solar photovoltaic cells, thermoelectric generators, thermionic converters, magnetohydrodynamic systems, all which will comes under these direct energy conversion systems, where there is no involvement of the rotating component. That is very important. And here, in this case of gasification systems, we are directly converting this biomass into producer gases of composition carbon monoxide and hydrogen. I will explain in the later part. So that where it should be coupled with any of the electrical generating equipments, or for the different applications, it will also be expected to be explained at the end of the session. So here the sustainability is also equally important whenever that we are finding the alternative sources of energy, and we need to take care of the existing resources in terms of the non-renewable energy resources. Perhaps the renewable energy resources is
File
also
version.
we need to be taken care, where we need to transfer this energy resources to the future generations. In that aspects, that whenever the generations is equal to the consumptions, so we call it as a sustainable solution, or we call it as a sustainability. So which is to prevent the depletion of the natural resources, and also to maintain the ecological balance. That's why we are obviously focusing on the sustainability. And when it comes to the renewable energy resources, or the scenario of our country, as we have promised in the Paris Accord on climate change in 2015, we have guaranteed that around 40% of the energy contributions which will be made from this renewable energy resources by 2030. And one more important thing I will tell you at the end of the session. So this 2030 is going to be the remarkable year for our country, when it all the promises are accomplished by the end of this 2030. So by the end of November 2020, the overall contributions from the non-conventional or the renewable energy resources, which was around 38% for our country, and around 21% of the total electricity consumptions which comes from this renewable energy resources. And the installed capacity of a country from the renewable energy resources are around 136 gigawatts out of our overall installed capacity of our country is concerned. Whereas in this biomass and gasification based combustion, and I mean the gasification combustion systems of our country is little low when compared to the solar and wind energy contributions, wind energy share of our overall installed capacity of our country. So with this note, we will be straight away, go to the introductions part. As we know that these the biohydrocarbons, or simply we call it as a biological matters or the biomasses, which are nothing but the biodegradable materials over the time or with respect to the temperature. And also these materials are found from, which can be derived from the plants as well as from the waste as from the animals. So the chemical composition of this, we used to say that is a hydrocarbon and also associated with some oxygens. So simply to say that glucose C6H12O6, and here we have mentioned the chemical formula of a generic biomass fuel is given in this presentation. And across the globe, many people, particularly from the developing countries, people are relying on this biomass for heating and cooking. Heating their households, if it is a cold climatic conditions or the countries, or they are mainly relying, particularly the African countries, they are relying on this biomass for cooking applications too. So around 2.4 billion people across the globe are using this biomass for meeting their basic cooking demand of their households. So these are the some of the biomasses. The classifications of the biomasses are given here. Woody biomasses, crop residues, and animal waste. Even then, every day, in a day-to-day basis, we used to have these biomasses for many applications, and which could be derived from the forest, or either from the forest or from the furniture shops as a waste, or from the agricultural lands after the post harvesting or the cultivation process. We used to get a lot of waste that is being burnt in the field itself, that was creating a lot of pollutions in our capital of our country. That was being highlighted before 2 years, the before this pandemic situations. So we need to address all these issues by the way identifying better solutions, by providing the better technological solutions for this case to convert. See, without burning it in the field, we can able to convert this into the useful form of energy. That might be either the electricity or the thermal energy, or for many applications we could consider to use this technological solutions. By the way, considering this waste biomasses taken from the field, agricultural fields, or you can also find out these biomasses, woody biomasses from the forest trees, and this can be used particularly for the cooking applications. So in some of the rural areas, particularly in Tamil Nadu, we used to say that Prosophis joliflora, that is nothing but the Seemakaruvai Lamaram in Tamil. So that is to be invasive trees, that is to be eradicated from the motherland. So that government, the judgment, even the our judges have made some stringent comments on this to the collectors of the district, a particular district. And these Prosophis juliflora was considered to be one of the main source of income for the people who was residing in that particular district, Ramna district, and near to that. So they used to convert this biomass directly into the charcoal through the charcoal making kilns. Whereas if they are selling this biomasses of, solid biomasses of these hydrocarbons in the market at 1 rupees per kilogram, 0.5 or 1 rupees per kilogram. But when they convert this into the charcoal, then they can sell it in the market at 12 rupees. So that is actually a good thing. As well as they are eradicating this invasive tree from the lands. So that is one thing. So the crop residues are given in this picture, where you would have been seen all these in your I mean, in your villages or from wherever it is accessible. The rice is bagasse. Bagasse is nothing but once after extracting the juice, sugarcane juice, the remaining residue is called the bagasse. And the straws, nuts, everything that could be considered as a crop residues. So the animal wastes are also used for, I mean, since the cow dung, poultry dung, and many of the animal waste could be processed and it can be used for cooking or for many applications. I would say one thing that this is the birth of the technology actually means the gasifier or converting of the solid biomass fuel into a combustible form of a gas is what being done at our taken gasifier systems. It is a birth of the technology. But whereas this could be even used for the death of the human being, I will explain you at the end of the session. So these cakes, cow dung cakes, can be processed and it is being used for cooking as well as burning of dead bodies. Okay, so this can be avoided because it is a pollutant means of emissions will be directly injected into the atmosphere, so which will be directly contributing to the global warming. So this can be even avoided through some adopting this technology called the gasifiers. So the energy content of a biomass is clearly depicted in this picture when the lower heating value and the higher heating value of biomasses, which would be, I mean, the energy content is nothing but it is a measure that is, I mean, when you are burning a kilogram of a fuel, how much quantities or how much the joules of energy was retrieved or emitted. This is what the energy content of a fuel. And as I was mentioned, in addition to this carbon, hydrogen, and oxygen, the moisture content and also the ash content is also being associated with these fuels. Hence, these moisture and ash content, which will create some adverse effects if the biomass having the higher amount of the moisture and ash content. So this could also be closely considered. I mean, we need to consider this moisture content whenever we are undertaking or we are choosing the type of biomass gasifiers are to be used for any specific applications. And then these are some of the main components. I'll skip this because you know what it is exactly, that cellulosic content, hemicellulosic, lignin content, and these three are will be considered for the calorific, I mean, or main sources of this energy content of fuel, calorific value of the fuel. And other water soluble sugars, ethers, alcohol soluble contents in the protein is also been associated with it. And here is the map, which was actually funded by the Ministry of New and Renewable Energy of our country to IISc Bangalore, and they have made I mean, utmost effort on creating this biomass atlas, and which was, I mean, you can see the table, sorry, figure, India map. So where almost all over the, I mean, each and every part of the country is having the abundant amount of the biomass. So the biomass potential is very, very high in our country. And since it is a renewable form of a fuel, you can, it is also in inaccessible nature of a fuel, so that we can consider this for our technological solutions for providing the energy for meeting the basic low demand of the rural areas and also even the urban areas. And this is the percentage share of the renewable energy resources of our country is given in the right hand side picture. So now we'll be moving on to the carbon cycle, where you can see that here I just wanted to make a point on the sun. So we know that the sun is a source for all renewable energy resources, non-renewable energy resource, and also living and non-living organisms present in this world, where this photosynthesis process, the growth of the trees are mainly through this photosynthesis process, where the carbon dioxide and H2O will be taken from the atmosphere and from the depth of the earth respectively, and which will be processed. And it will be, I mean, the carbon, hydrocarbon will be stored in the stem of the trees. That is the growth of the plants. And this hydrocarbon stored in the stem of the tree will be utilized. I mean, it is not about the stem, but also you can use the stalks and also the leaves, anything. Okay. So wherever that we can find out the hydrocarbons, then you can make use of it in the gasifier technology, and this process is called the gasification, where we used to produce the producer gases of composition carbon monoxide, hydrogen, a very little amount of methane, and also carbon dioxide and other things. But in the syngas, the purest, I mean almost the carbon monoxide and hydrogen, limited methane content will be present in the syngas, and this can be taken for, I mean this can be used for many applications. I would say that for engines you can directly inject into the gas engines, so that you can generate a power, and also you can burn it in the burners, and you can use this in gas for many applications for the combustion processes. Again it will be, I mean the carbon dioxide will be ejected into the atmosphere, and this will be taken again in the next cycle of photosynthesis process. So this is called the carbon cycle. I hope I am audible. Professor? Hello? Hello?
Yes, sir. You are audible, sir.
Okay, sir. Okay, sir. Please, I think I'll please let me inform, sir, because I mean I don't know whether I am connected with you or not. So please let me inform if my voice is breaking or if I am disconnected. Please let me inform, sir.
Yes, sir.
Or
Sure, sir.
I'll confirm with you. Okay.
Okay, sir.
Okay.
Okay, sir.
So here the biomass conversion into the energy is clearly depicted in this picture, where you can see that the solid hydrocarbon or the biomass can be processed into the energy through three different ways or routes. One is a thermochemical route, another one is a biological route, final one is a physical conversion routes. This is nothing but the mechanical route, where in the physical conversion routes we used to take the seeds or any other materials which contains the oil, or some of the, I mean sugar canes which contains the juice, sugarcane juice, which can be obviously squeezed, and the final form of the oil or the juices can be used to convert into the I mean in the fermentation process we can make it in the form of alcoholic content, ethanol. And also in the biological route, then the air, I mean without presence of this oxygen or no interaction of this atmospheric air with this solid biomass, which is blended with the water, which is taken into the I mean the digester, and the I mean good bacterial actions will be taken, organic bacterial actions will be taken into the digester, and we could be produced with the methane and carbon dioxide of composition called the biogas. That is something different from the producer gas which we get from this gasification process. So in the third route, where we are particular about this gasification, which comes under this thermochemical route, where the combustion, pyrolysis, and the gasifications are the three different mechanisms, or even the carbonization. There is no much difference between the carbonization and the pyrolysis process, where we used to produce the carbon, charcoal, as a resultant product. In the pyrolysis process, we are expecting the bio oil. We can get the gas, condensed once if it is condensed, then bio oil, then we can expect the charcoal and the gases direct for the direct combustion. In the combustion process, if we substitute, it is direct combustion, where the excess amount of the air is supplied for complete combustion of this hydrocarbon. We can which is nothing but the liberation of the heat, is what the final expected outcome of this combustion process, where we can get the heat, and the flue will be into the atmosphere. In the gasification process, the solid hydrocarbon fuels will be converted into a combustible form of a producer gases of composition carbon monoxide and hydrogen. This is the beauty of this gasification technology. So some of the other gasifications, I mean the agents used, air, steam, oxygen, and hydrogen, which we can use as a gasifying agent, and we could expect it to have it done for different applications, whatever that. If you are particular about the power, steam, gas, or synthetic liquids, you can concentrate on the different types of gasifying agents, so that the expected outcome can be achieved. So here as I was mentioned, the biomass can be directly converted into a producer gases through this gasification technology. And you look at this picture, which could explain you about all together in a simple and single picture. where the gasification, this is a solid biomass fuel. Once the heat is supplied, that is why we used to have the red phosphorus at the end, in the tip of your matchsticks, and where the heat is, I mean, this is for the ignition purpose. So once the ignition process is over, then the heat will be obviously transferred through the hydrocarbons. Then the, I mean, insignificant, see, inside of it, the charcoal is produced through this pyrolysis process. This pyrolysis is inside of the flame because insignificant supply of the oxygen is taken place. But in the gasification process, a little around this pyrolysis process. Next layer of this, I will explain you with the equivalence ratio in the next slide. Here the producer gas or syngas will be coming out, and which will be continues to burn is called, with once interacting with the sufficient amount of the atmospheric air, is called the combustion. So there is a lot of differences between these three, but obviously that all together is taken place in any of the combustion reactions, first of all. So the different layers and its temperatures are given in this picture, in the right hand side picture. So see, this is very, very important as far as the any type of combustion, gasification, pyrolysis, or the carbonization process are concerned. Because in the combustion process, we used to conduct it at the equivalence ratio. Of equivalence ratio is nothing but, you know what, the air fuel ratio of the actual to the air fuel ratio of the stoichiometric. When this is around 1 or more than that, the stoichiometric air, see, excess amount of the air will be supplied for the combustion process, so that the complete combustion of this hydrocarbon will be taken place, and the remaining part is going to be the H2O or the carbon dioxide. But whereas in this gasification or the pyrolysis process, it is conducted at substoichiometric case, where the equivalence ratio would be nearly around 0.2 to 0.3. So the gasification, I mean, gasifying agent is of oxygen if it is purest form, if you can supply the oxygen purely, or we can take the atmospheric air, and based on that we need to have a separate calculations on that. And also the pyrolysis is very limited amount of the air or no supply of the air. Parallelly, that the pyrolysis and carbonization are almost same, only the difference, temperature difference, which makes some sense in differentiating these two. And then the principle, I mean, the already told you that excess air is supplied, then the actual combustions can be attained. If you are I mean, if based on the chemical calculations, chemical reactions and its calculations, we have predicted the amount of air needs to be supplied for the combustion or the any process, it is called the ideal combustion. It is the stoichiometric air, exact amount of the air will be supplied, but you cannot achieve the actual combustion because we need to supply the excess air for the actual combustion. Here in the stoichiometric case, we are limiting the air supply so that the direct conversion of this solid biomass to the combustible producer gases can be achieved. Look at this here, the C6H12O6 form of a hydrocarbon will be reacted with oxygen and the steam. If it is steam, then you are expected to have much more hydrogen in the outcome. Then you can supply the steam gasification technology is also practiced for many applications. And here, if this part, I mean, before in the left hand side dotted line, the left hand side part is a gasification zone. Once the air is additionally supplied in the combustion zone, the oxygen would also be found in the flue gases, and the H2O and the carbon dioxide or the resultant product. But when it comes to this gasification area, where you can get carbon monoxide, hydrogen, further these two are the combustible. Still, you cannot combust this carbon dioxide, that you know. So these two can be achieved based on the amount of air supplied. So in the gasification process, this is the actual step-by-step procedures involved in the top two, in the I mean, adding of the solid fuel into the generation of the electricity. See, this is not only for the electricity generations, as I was likely mentioned at the beginning of the presentation. It can be used for many applications. I will explain you at the end. Here, once the I mean, the producer gas is supplied to the engines, then you can couple with the generator, so electricity is being produced. That's what I have been given at the bottom. But the solid biomass is, once it is taken into the gasifier, first process is called the drying. So the water content will be removed. So the second process is a devolatilization process, and then the combustion will also be parallelly taken place. Here the air will be supplied, and these are the carbon based reactions which should be expected in the gasifiers. Carbon may be reacted with oxygen, produces carbon monoxide. If it is complete combustion, then the carbon dioxide will be the resultant product. Once the red hot char through that the carbon dioxide is passing at high temperature, what happens is that this carbon dioxide and carbon reacts together and produces the carbon monoxide, because it is further is a combustible in nature, so that it is a composition what we expected to have it done in the gasification process. Here the carbon is also, once the moisture contents are evolved and it is reacted with this, it will be resultant to the production of carbon monoxide and hydrogen. This is what exactly we want. But all the other component will also be produced through this combustion, I mean the gasification reaction. And the producer gases can be further cleaned by removing, for removing the hydrogen sulfides, ammonia and the particulate matters, using the dry filters and the wet filters all together will be connected, coupled with this gasifier unit, so that these contaminants can be eliminated. Further, the purest form, the tar is also one form that it forms some clocking of your piston and cylinder in the engines, so that the tar content should also be reduced to the maximum extent. I will tell you. Based on that, the selection of the gasifiers can be made. So this is obviously, as I said, there are 4 reactions. One is drying, pyrolysis, combustion, reduction, all together parallelly involved in this gasification systems to produce the gasifier. So all the other reactions have already been discussed. So I'll be skipping this. And here I said drying process is driven. I mean the water content will be driven off is called the drying, as we know. The pyrolysis is heating without supply of oxygen or very limited supply of oxygen at lower temperature. The combustion or the cracking of the tar content will be parallelly performed, because at high temperature it will be, the tar content will be cracked, and the aromatic and other forms of the combustibles are evolved out of this cracking of the tar. Finally, the reduction, where the carbon dioxide through the combustion process will be passing through the red dot chart, so that the carbon reacted to carbon dioxide produces the carbon monoxide. Again, this will be the producer gas. The part of the producer gas. So this is the actual picture which has been taken in the operating gasifier at Chennai. So here the 4 different processes are clearly explained in this slide, where the heat is applied for driven off the H2O content. Once the heat is applied at 105 to 120 degrees Celsius, the all moisture content at the different layers of the biomass will be evolved, and which will be getting out of the biomass. Then the second process, no air or minimum air, the heated biomass will be giving out the tar content, and the remaining part is charcoal. And this charcoal, carbon dioxide or the air will be passed through the charcoal, and the carbon dioxide and also H2O will be evolved out of it. Then this will be passing through this red hot char. As I was mentioned, this is called the reduction process. Finally, the carbon monoxide and hydrogen will be produced. So here I have given the table which would compare the gasification combustion process. So in the gasification process, what happened to the carbon in the gasification, which is expected to convert this into carbon monoxide, but whereas in combustion process, it should be converted into carbon dioxide. For hydrogen, it should be hydrogen, but here in the combustion process, H2O, the resultant product. Nitrogen will be as it is, but here the NOx will be formed, since the excess amount of the air is applied at high temperature. So here the sulfide content will be converted into hydrogen sulfide. We have some sort of eliminating this hydrogen sulfides as a technique. So I would also tell you in the next slide. So in the gasification system, we have been expected to have these syngases or the producer gas, but in the combustion process, the exhaust gas or the flue gas will be the resultant product. So these are the combustion reactions. Carbon must produces carbon dioxide. Hydrogen produces H2O. This is the actual reactions taken place in the combustion process. But when it is a gasification reactions, we have a heterogeneous and homogeneous gas phase different reactions. where in the water gas reactions, H2O will be reacted with carbon, produces carbon monoxide and hydrogen. So moreover, the carbon monoxide produced reactions are the endothermic reactions, but whereas in the carbon dioxide produced reaction is as an exothermic reaction. These are all the different phases. One is a liquid, it is a solid, produces the gas. These are all the different reactions, Board reaction, methanization reactions, but these are the heterogeneous reactions. But this is to be converted into homogeneous gas phase reactions, where the carbon monoxide reacted with H2O produces carbon dioxide and hydrogen. All are the homogeneous reactions. So some of the gasifier technologies, different types of gasifiers are given in this picture, where you can see the updraft gasifier, downdraft and crossdraft gasifiers, and one more is called the fluidized bed gasification systems, expected to be explained in the next slide. Here the efficiency of this updraft will be very high than that of the downdraft and the crossdraft. Also the other forms of gasification technologies are concerned. But in the updraft systems, one problem is that it produces the large amount of the tar content and the gas, which would also be expected at 400 degrees Celsius. But when it comes to the downdraft gasifiers, the temperature of the outside gas is very high and the tar content will be very, very limited, minimal, so that for gas engines based power generation systems would preferably have this downdraft gasifiers. In recent time, that hydrogen production is also been keen interest of the researchers from this downdraft gasifiers and not by the updraft gasifiers. But this updraft gasifiers can be widely used for cooking applications, where are the thermal applications directly. If the heat is required, then we can preferably take this updraft gasifier. But in the crossdraft gasifiers, the initialization is very easy, and also the size of the system is very small when compared to the updraft, because this updraft is very, very high. So these are all the pros and cons of this gasifier systems. I said co-current or counter current or the updraft gasifier systems, where the air will be supplied from the bottom through the perforated plate. This is called the grate. And on the top, we will be having the fuel feeders. The fuel will be feeded from the top and the air will be supplied from the bottom, so that called the counter current, and the gas can be extracted on the top of it. So as discussed, the thermal efficiency will be high, exhaust gas temperature will be very low when compared to the downdraft gasifier and the crossdraft. This is the different stages, drying zone. When the fuel is feeded, initially that the temperature would tend to driven off the water content possessed in this biomass fuel or the any fuel which used to take it in the gasifiers. And the pyrolysis, since there is no supply of air or minimum supply is interacted, we call the pyrolysis reaction. Oxygen is initially interacted to the biomass is called the oxidation process, where in between the char is produced and the char content is reacted to carbon dioxide, produces the carbon monoxide, taken place in the reduction part. Ash will be collected at the bottom. As this is a perforated plate, the ash content can be collected at the bottom of the system. So this was already discussed, the different reactions taken place. I would see, look at this picture where the fuel feeding can be through the screw conveyor, and this can be, see, red dot chart is also visible. The gas produced was collected on the top of the system, so that it is an updraft gasifier. Here in the co-current gasifier or the downdraft gasifiers, the pros and cons was already discussed. Here you look at this, the air will be injected at the top and the gas will be collected at the bottom through the perforated plates. So this sort of arrangements is called the downdraft gasifier. So these different layers are obviously you would literally see the differences between this updraft and downdraft gasifiers. So we will go to the next process called the crossdraft gasifiers. So I was told you that the simplest form of the gasifier is crossdraft gasifier. And whenever we expected to have the quick start of this biomass gasifiers, then we would preferably take this crossdraft gasifier. Whereas in the fluidized bed gasifiers, where the sand bed is maintained on the perforated plate called the grate, and air will be supplied at the higher velocities from the bottom, so that the pressurized air will be used here as a gasifying agent at very high superficial velocities, so that this sandbeds will be moving. I mean, it will be creating a kind of a fluidization. This is nothing but due to the higher velocity, the sand will be floating in the air. So that any type of the advantages of this system is uneven sizes of the fuel could be used, and also the higher torque content of the product gases is one of the drawback, and also the circulating, it is a circulating fluidized bed combustion, I mean the gasification systems, where the sand particles and other sort of ash content, everything will be circulated again back through the cyclone separators, and it will be again feeded into the gasifier, I mean the fluidized bed gasifier, as to maintain the thickness or the bed size of the bed continuously. So the temperature of the, see in the gasifier, the even temperature will be maintained from the top to bottom of your fluidized bed gasifiers. That is one of the advantages. And also the smaller particles can be used in this gasifiers, because whereas in the updraft and downdraft we could not use that because of some I mean it will fall down through this perforated place, but here the superficial velocity is employed so that we can use, and the operating temperature will be very low when compared to the ash fusion temperature, so that the clinkering effect can be drastically reduced, so that this system, fluidized bed gasification systems, can be preferably considered for this kind of applications, so that the startup will be very easy, so that once the this fluidized bed gasifiers are used, so that the heat can be externally, the fuel will be initially that it will be heated up from the outside, but all other considerations, updraft, downdraft and cross drafts are heated up in the system itself. So loading flexibility is there, heat transfer rate will be very high, and the fuel flexibility, as I was mentioned, that you can use any type of a fuel. So the you can use this as a moderate oxidant, and the steam requirements, temperature will be maintained uniformly in the system. Coal gas efficiency of the system will be very high. I mean the biomass to the conversion into the producer gases will be very high. So some of the advantages and disadvantages was already been discussed. So by considering the time considerations, I would skip all these comparisons, because I was already been discussed. So this is going to be the typical composition of your syngas produced, I mean the producer gas produced, where around 20 percentages of carbon monoxide and nitrogen respectively could be found. And the calorific value of the system is also which would vary from 1000 to 1300, but recently we have achieved 1500 in one of our collaborators gasifier, downdraft gasifier. And the methane content would be in the range of 2 to 4, which is traceable, but that is not much in this producer gases. So some of the purification of the gas is also given. Precipitation techniques can be adopted, hydrolysis process, adsorption, sulfur recovery. Through the hydrogen sulfide, we used to supply the oxygen to produce the sulfur content, so that it can be easily be removed. So membrane technique is also recently adopted for purifying this producer gases, so that we can convert this into a syngas for supplying the system in direct applications. So water gas equilibrium reaction is given in this, and the equilibrium constant is also for different temperatures. Theoretical temperatures are given in this. It was also parallelly tabulated in the right hand side. So where you can see that the higher the temperature, the value of the, I mean the equilibrium constant would be very high. If the temperature decreases with respect, I mean this KWE value, equilibrium constant value, would tend to decrease with respect to the temperature. Once it falls below 700 degrees Celsius, we call it as a frozen state of the gasifier, because the KW equilibrium, water gas equilibrium constant, would be very low. And here the I mean the chemical, sorry, gasification efficiency, mechanical efficiency of the gasifier, and also the thermal efficiency of the gasification systems are given, so that you can preferably refer to this graph where the carbon dioxide and the hydrogen content would be increasing with respect to the moisture content. If the moisture content is very high, you can preferably go for updraft gasifiers, but the downdraft gasifiers you can use only up to 15% of the moisture content. That is one of the drawback of downdraft gasifier, where the carbon monoxide is also decreasing with respect to the moisture content of the wood. So some of the woods or the fuels could be processed and it can be used in the gasifiers are given in this table. Chaff cutter, where the process is juliflora, as I was mentioned, that the Sema Karavalam in Tamil. So it can be found across the state, and it is an invasion and it should be completely eliminated from the land. So some of the other wooden pieces, coconut shells, since we are the leading producers of this coconut according to the United Nations. So we are producing 11 lakh tons of 1 crore and 17 lakh tons of coconuts every year. Particularly from the Kerala and Karnataka, they are the largest producers of our country. Still, our Tamil Nadu, state of Tamil Nadu is producing 31% of the coconut in India. So some of the other technologies of these biomasses, see, it is artificially created biomass, nothing but loosely bonded molecules of the hydrocarbon fuels. For example, the bagasse and the rices, sawdust could be collected and processed and at high pressure, more than 20 megapascals or more than that. The bulk density can be increased so as to decrease the occupied volume of the sawdust, rices and other bagasses wastes, so that this size will be reduced and the calorific value, heating value of the fuel can be increased by increasing the density of the fuel. So these are the tested, some of the test which was carried out, where you can see that the moisture content eliminated and endothermic and exothermic reactions of the fuel. So all these could be found from this published paper. And the utilities, where the thermal and electrical applications of using these gasifier technologies are going to be discussed one by one. Here some of the technologies or some of the applications of your gasification based thermal systems are given, starting from hot air generator, dryers, boilers, thermic fluid heaters, furnaces and kilns, ovens, everything that you can use it by considering this gasification technology. Heat content of that fuel is 5 megajoules per normal meter cube, and the flame temperature is also very high. So some of the applications, bleaching applications, it can be replaced with the conventional. Ancestors followed this conventional bleaching techniques, but now it can be replaced by gasifier based bleachers. And the chemical production units also, see, these are all the some of the practical examples done by our professor from Anna University, Dr. Sethumadhavan. And the cocoon cooking oven, where the silk can be produced by using this gasifier based technologies, where the fuel consumptions can be reduced and also the water consumption for the cocoon the cocoon processing by 50% around. So in the dyeing industries, they are also have reduced their curtailed their usage of the biomasses by 50%. And it is also one thing that we need to consider is starting from three stone firing to the improved chullas. And in recent time across the globe, many premier institutes like MIT, in Massachusetts Institute of Technology, in the D Lab, Design Laboratory, and the National Lawrence Berkeley's Laboratory, Oak Ridge Laboratory, Colorado State University, the Energy and Resources Institute, Indian Institute of Science, Bangalore, IITs, VIT, and also online universities all over the world and country. They are keen interested in this cook stoves manufacturing. Here it is the Berkeley's laboratory created the first stove is given in this picture. Here the EnviroFit stove, I mean the natural draft stoves. But we have created, see in IIC Bangalore, they have created the Urja Plus stove in previous years. And in Terry and Philips, they have developed Terry SPT cook stoves and the Philips cook stoves. And even I have fabricated and designed and fabricated the stove and tested in our laboratory, so that it was published in many reputed journals too, so that the embodied energy and the embodied carbon dioxide emissions was estimated for our stove. And the economical and also the emission reduction certification of the emission reductions is were also been given. Carbon payback period is also given. The annual carbon dioxide mitigation potentials, see this is very very important. Three stone, I mean the traditional cook stoves, when it is compared, the improved cook stoves are compared with the traditional cook stoves, they have curtailed around 212 metric tons of carbon dioxides every year. But even then, we have designed and fabricated, tested the system. It was proven that 428 or 420 8.6 kilogram of a carbon dioxide, metric tons of a carbon dioxide was mitigated when it is compared with the traditional cook stoves. So some of the electrical applications where the biomass can be directly fed into the gasifiers, produces the syngas, and it can be cleaned up and it will be directly injected with diesel. 80% of, see, this is practical. See, this is the gasifier which is installed at VIT, Vellore Institute of Technology in the Carbon Dioxide and Green Energy Technology Center, where this is the capacity of 100 kilowatt electricity, where the syngas produced will be injected 80%, and the 20% was the diesel. So this is a diesel fuel engine, dual fuel engine of capacity 130, manufactured by Kirloskar, where it can able to meet the hostels, I mean 3 hostels of our campus. So boys hostels, so that it is driven by the gas genset, I mean the gasifier based gas gensets. And we have been recently sanctioned with a project, an amount of 1 crore and 8 lakh rupees. I am the principal investigator of this project, where the biomass gasifier based system for producing the gas, and it can be used for 3 different applications, proposed for 3 applications. One is for community cooking at school, and the cold storage systems using the vapor absorption machine, ammonia water vapor absorption machine, so that the cold storage can be useful for the farmers of the particular scheduled tribe community of Yelagiri Hills. And the producer gas driven gasoline engine for electricity generations, which has been projected for primary health center and the electric vehicle charging stations for tourism, for promoting the tourism. And then this is also one sort of other applications where we have been sanctioned with 1 lakh rupees from the VIT incubation center, where the biomass gasification system based burner, and parallelly this can be used for cooking, and the remaining flue can be supplied to the greenhouses for carbon dioxide sequestration process. So some of the other applications and the power generations can be used for the rural areas, for many applications such as pumping and irrigation process, electrification of the particular villages, captive power for the industries, and also grid interacted systems too. If it is connected to the grid, so that the power can be expected at any point of time. Once the captive power is not utilizing the power, so that the power can be used for many applications. So you can be benefited out of the electricity exported to the grid. So as I was mentioned, that starting from the birth of the technology to the death of the human being, where the special applications is given, where for complete burning of a body, dead bodies, it is a highly inefficient and energy intensive, where it consumes around 600 kgs of the wood for completely burning the body. So whereas if you are considered, see some of the crematoriums in Chennai, see around 44 crematoriums there in Chennai. Out of that, 22 are the gasifier based crematorium in the greater Chennai. So, and also which has been, some of the informations has been taken from Moksha, I mean non-profit organizations of our country, where 50 to 60 million tons of trees are burned every year in India. Since 7 million or more than that of the Hindus are dying every year, they are burning their bodies using this biomass, so that it is accounted around 8 million tons of the carbon dioxide into the atmosphere. So that so green cremation, as I was mentioned, that gasifier based cremations can curtail the carbon dioxide emission into the atmosphere of 60 percentage for every year. So in the left hand side, the gasifier based crematorium, where it is consuming only around 150 kilogram of biomass, but in the normal open cremation process, it was consumed around 600 kgs of biomass for a dead body. So it is the electrical based cremation process, which consumes 125 units of power per body. So just imagine and compare the cost of burning a body. So that what is the need, or why you want to have this technology, gasification technology? It's a clean technology. So as I was mentioned, in the carbon dioxide cycle, where the carbon dioxide, it is a carbon dioxide neutral. Even to say that positive carbon dioxide, sorry, negative carbon dioxide, actually we are completely mitigating the carbon dioxide emission. And then it is a renewable fuel is used, so that the green technology, and wherever the decentralized power generation is to be adapted, then you can preferably go for this gasification based electricity generations. And here in the way forward, so that the schools and college laboratories should have the gasifier based experimentations for demonstrating to the future pillars of our country. And also the financial supports and the research fundings, and also the subsidy should be given to the investors on these gasifiers. And microfinancing and the repayment opportunity should also be given to the people, those who are interested in doing this, or interested to install this gasification based technologies. So some of the research and development projects should be sanctioned in this field for promoting these gasifier based technologies for the green future of our country. So I was mentioned that as the government of India was promised in the accord, uh, Paris Accord, by the year 2030, 40% of the energy which would preferably come from renewable energy resources. Likely, our former President of India, Dr. APJ Abdul Kalam, was also delivered a speech on 2000, the Independent Day in 2005, stating that by the year 2030, our country should be independent. It should achieve the energy independence through the solar energy and other forms of the renewable energy. So one form is a gasifier based biomass supplied gasifier technologies. So that's all. So I thank our Honorable Vice Chancellor of our university, and the Vice President's Vice Chancellors, Pro Vice Chancellor, and also the Registrar, and my guide, Dr. Inian, sir, and our Dean and HOD of our school, our colleagues, and the professors of our university, and other universities who have supported so far, and also the DST for sanctioning the project towards the welfare of the scheduled tribes of our state, our country. Thank you so much. Thanks for the opportunity. I take this opportunity to thank the management of Power Engineering College, the professor and principal of Power Engineering College, and the head of the department, and the professors the coordinating professors of this event, and moreover the participants. Without them, any event cannot be successful. So I take this opportunity to thank all the participants for your patience listening. Thank you so much. Thank you, one and all.
Thank you so much, sir. Thank you. Really, your presentation is so valuable, sir. Dear participants, any queries?
Sir, good afternoon, sir.
Yes,
This
sir.
is
Good afternoon.
Yes, sir. Good afternoon,
Sreshtan
sir.
from Namakal.
Good
I'd
afternoon,
like to take some research work related to biomass gasification.
Yes,
Could you could you advise me and recommend some topics related to this, sir?
definitely, sir. Sir, you can contact me personally, sir. So you
Yeah,
can
okay.
also directly be in contact our, our research team, and we can also support you in terms of, within this scope of this research. So that if you are interested, then you can contact, sir. We can have a collaborative research too.
Okay, sir. Okay. Thank you.
Sure, sir. Definitely, sir.
Good afternoon, sir. This is Lenin.
Good afternoon, sir.
Sir, which technique is suitable for agriculture sector, sir? Actually, like so, minimum capacity. For minimum capacity, which type of technique is suitable, sir?
Sir, actually, for that is based on the applications, sir. If you are looking for the thermal applications, you wanted to completely make use of the hydrocarbons or the stocks and other post-harvested process. We are getting some hydrocarbons now, so that can be used in the field itself. If you are looking for, then you can go for thermal applications. Then updraft gasifier would be preferably taken, sir, because the tar content will be high, but for combustion process, we are not bothering about the star content. So for this system, many industries are having this gasifier based thermal energy systems, so that you can, if you want, then I can also give you some contacts, sir.
Okay, sir. Fine, sir. Then one more question: that
Yes, sir.
what is the minimum plant capacity that is commercially available in the market, sir?
Sir, even 5 kilowatt or 10 kilowatt system is also available, sir. That depends upon the application, sir.
Okay.
If you are looking for continuous feeding, it can be for batch feeding, sir. If you are looking for a continuous feeding and you are expecting for,
Okay, sir.
that depends upon the application. For electricity generations, you cannot go with the minimum capacity. For combustion
Okay.
or for
Yes.
cooking
So what will be?
applications or for,
Yes, sir.
yes, sir. Yes, sir. Yes, sir. Tell me,
What
sir.
will be the cost of that plant, sir? That means if we are taking that 5 kilowatt plant, so what
Yes, sir. Yes, sir.
will be the cost
Sir,
of that, sir?
mainly per kilowatt, it would comes around 40,000 rupees or 40 to 60,000. That depends upon the facilities and the technologies they are providing. The cleaning of the gas. That depends upon the application, sir. Because if you want the clean gas, then we need to have many. The cyclone separators, then the bag filters, dry filters, wet filters. Then based upon that, and also if you are looking for automated system, for fuel feeding there is of automated system, sir. So if you are looking for, then the cost may be 60,000 per kilowatt, or otherwise 30 to 40,000, sir.
Thank you so much, sir. Thank you so
Thank
much.
you, sir.
Any other questions? Now I would like to call Dr. Jagdishan sir for a vote of thanks. Jagdishan sir.
Yes, sir. Professor Dr.D.Sakthivadivel, sir, thank you so much for your valuable presentation regarding biomass. I hope from your presentation, our participants get the knowledge about the biomass and various types of biomass and what are the process occurs in the gasification process, and also we are getting the knowledge about the various applications of biomass and applications of gasification also. Thank you so much, sir, for your valuable presentation and spending your valuable time with us. Thank you, sir.
Thank you, Professor, for your opportunity.
Okay, thank you, sir. Always welcome, sir.
Thank you, one and all. Thank you so much. Thank you, Professor. Yes, sir.
Thank you, sir. Dear participants, your feedback link will be on the chat box.
May I leave, sir?
Okay, sir. You can leave, sir. You can leave.
Thank
Thank you,
you,
sir.
sir.
Thank you, sir.
Excuse me, sir. Do you post recorded lectures anywhere?
Sir, I got it, sir.
Sir, do you share recorded lectures on other platforms like YouTube?
Yes, sir. After completing this 6 days program, we will post all the videos in YouTube, and we will share that link to you, sir.
Okay, thank you very much, sir.
Okay, sir. And also, if you need any separate paper, sir, PPT, We will share you, sir.
Sure, sure. Now, actually, I today joined late, so that's why I wanted. Okay, sir. Thank
No,
you.
no issue, sir. You can just mail it, sir, and we will share that. Okay.
Oh.